Hello, everybody. Today we are going to talk about 12-point AC confidence of interval for means. So we are going to compute the margin of error and create a confidence interval by using sample means and sample standard deviations. In the last lesson, we did it by using sample mean and just standard deviation, which is a population standard deviation, right? You know, you should understand what it means, population and sample. Population is everything, all the data, and you get the sample, small portion of a data from that population. That's the sample, right? So you should understand the difference between population, everything, and sample. You get the sample from the population. So today is when you know sample means and instead of population standard deviation, now you are using sample standard deviation. That's the difference. So only in this case, only the formula first, the margin of error will be slightly different. That's it. All right. So let's review what we did last time a little. So confidence interval is sample mean minus margin of error, sample mean plus margin of error. That will be the interval. And how do you get the margin of error? Last time we get when we know the population standard deviation, right? When you know the sample mean from here, 1 standard deviation, 2 standard deviation for 95%, 1 and 2 standard deviation 95%, that will be the confidence interval. So you know the 95% 2 standard deviation. This symbol is the population standard deviation, right? So population mean, you write down like this. Sample mean, you write down X bar. Population standard deviation, you write down like this. Sample standard deviation is as X like this. Population, sample. You understand what it means? What is the difference between population and sample, right? Now let's see. Last time we did this, right? We know the population standard deviation and sample mean. Then confidence interval, 95% confidence interval was when you know the mean, sample mean and population standard deviation, you just simply mean minus 2 times sample, population deviation, right? Standard deviation like this. And then this is a interval and you got like this. When you know the population standard deviation, you just subtract or add 2 times of this. It's already given, so you don't need to calculate it by yourself, right? But now, today, a problem will give you sample mean and the same sample standard deviation. When we have a sample data, but we put it into the calculator, we know how to get the sample mean and sample standard deviation, right? So let's read the problem. That's the answer interval. And what it means in this case, we are 95% confident, okay? That the interval 17.70 to 27.30 contains the true average running time for a 3-mile run. That's the meaning of this. But now, when you have a mean and sample standard deviation, okay, sorry about here, sample standard deviation is given, then margin of error is, this S is a sample standard deviation. So 2 times sample standard deviation divided by square root of sample size n. That's the margin of error. All right. So this is competence of interval. Same competence of interval is mean minus MOE, mean plus MOE, right? So let's look at the question. Even though the question is very long, let's simplify. So when you read it, a baseball podcast claims that to each shareholders that the mean number of minutes listeners to tune into the podcast is 27. Mean number of minutes is 27. The station conducted a survey separately. Now you see they conducted a survey of how many 600 listeners, and will be 600, right? And then when you get the survey, the data, put into the calculator, and the sample stats are shown below. Sample mean give you 27.55. Sample standard deviation is 15.057. So a simulation was run 1,000 times based upon the results of the survey. Based on the results is the claim that listeners tune in to the podcast on average 27 minutes plausible. When the mean and sample standard deviation like this, average is 27, is okay. When 95% is this in the interval, it means plausible means. So you remember, how do you find out the competency interval? And if this mean fall in the interval is plausible, is out of the range, that is not plausible, right? So we should get the competence interval, but we get the formula a little bit different. So you remember the formula? So that was the margin of error, okay? If you have a standard sample deviation, 2 times that standard deviation. But now it's a sample standard deviation, 2 times sample standard deviation, but divided by square root of numbers, the sample size, m. You put this more. 2 times sample standard deviation, 2 times population standard deviation, similar, right? 2 times sample standard deviation, but when you use a sample standard deviation, you should divide by square root of the n. That's the difference. Not completely different formula, right? Only this is different. So let's go like 2 times sample standard deviation was 15.0457 divided by square root of what? N was 600, which is 1.23. Then your interval will be, confidence interval is now you know that this sample mean minus MOE, sample mean plus MOE. So you have sample mean was 27.55 minus 1.23 and 27.55 plus 1.23. If you get it, the interval is like this. So if your mean is falling in this range, then that will be plausible. So what was it? It was 27, right? Yes, 27 is in this range. So your answer is yes, the claim that listeners tune in to the podcast on average for 27 minutes is plausible, since 27 falls within the interval. Do you understand? So you can try one more time with a similar but different numbers. 114 students sample size, and find the mean of 195 messages per day with a standard deviation of 73 messages. From the sample, you get the mean, you get the 73 messages, right? Then can you find out the confidence interval? From here, what's the mean? 195, right? And the n, 114, 114. Sample standard deviation, you get this standard deviation from the 114 sample, so that is 73. The margin of error is 2 times sample standard deviation, and then difference divided by square root of n, which is 2 times 73 over square root of 114. If you did, margin of error is 13.67. And what do? Confidence interval 195 minus this, but this is, we round to the whole number, so 14. So 195, 14 is 181, right? 181. And then if you add to the here, you will get 209. That will be the confidence interval. All right, that's it. We'll stop here.